Welcome to the deep dive. Today, we're really getting into the nuts and bolts of Python.
That's right.
We're using Clarence Patterson's book, Python, Learn the Basics Fast from Python Programming Experts, as our guide.
Yep, a quick look at the fundamentals.
Exactly. Our mission, really, is just to pull out those key concepts, understand why Python is so popular, so powerful, and do it efficiently.
And not just list facts, right? We want to understand the why behind it, based on Patterson's take. It's about, efficiency, but also clarity.
Okay, so let's kick things off. Patterson starts by calling Python object-oriented, kind of like Java, Perl, Scheme, Ruby, languages some folks might know. But what makes Python stand out in that crowd? What's its main appeal?
Well, the first thing the book really highlights is its readable syntax.
Readable how?
It's code that's designed to be clear, almost self-explanatory in a way,
Okay.
which is, a massive plus. Makes it easier to write, easier to understand later, easier to fix.
Right. Less like cracking a code and more like reading, well, English.
Sort of, yeah. It aims for that kind of clarity.
That sounds good.
Yeah.
And it's not just about looking nice, is it? Patterson mentions a comprehensive standard library. What's that all about?
Ah, that's a big one. Think about common tasks, like handling files, searching through text.
Regular expressions, stuff like that?
Exactly, or connecting to servers online. In a lot of languages, you'd be writing chunks of code just for that basic stuff.
Okay.
Python's standard library, it comes packed with pre-built tools, so you can do those things with just maybe a few lines of code.
Wow. Okay, so it saves a lot of groundwork.
A huge amount of time. Lets you focus on what's unique about your project,
Yeah.
Not reinventing the wheel constantly.
Makes sense. The book also mentions it's good for workable interfaces for applications, so it's not just back-end stuff.
Oh, definitely not. People use it for the parts you actually click on and interact with.
Right.
And another key thing Patterson emphasizes is its cross-platform nature.
Meaning?
It runs pretty much everywhere. Mac OS, Windows, Ubuntu, other Linux versions.
So you write it once,
Mhm.
and it, well, mostly just works.
Largely, yes. Which is crucial today, with everyone using different devices.
Yeah, absolutely. Okay, this is where Patterson really sells it. He calls Python easy to use, says projects get done in no time. How? What makes it so fast and simple?
Well, part of it is being a high-level language. You're thinking more about the problem you want to solve.
And less about the computer's internal workings.
Exactly. Less about memory addresses and things like that. That readable syntax we talked about, that's a huge factor too. And Patterson points out it's great for prototypes.
Like quickly testing an idea.
Precisely. And also for ad hoc programming, those little one-off scripts you need to write quickly to solve an immediate problem.
Gotcha. And it seems flexible too. The book says it can be conveniently expanded with C++ or C code. Why would you do that?
Performance, usually. Sometimes you hit a bottleneck, a part of your program that needs to run really fast.
All right.
C and C++ are known for speed. Python lets you plug in those high-speed components where needed, so you get Python's ease for most of it, and raw speed where it counts.
Best of both worlds then.
Kind of, yeah. And a massive bonus, Patterson makes sure to mention, it's free and open source.
Right. No cost to download, use, change it, share it.
None at all. That lowers the barrier to entry significantly.
Okay, so that's the big picture. Then Patterson starts digging into some language-specific qualities. What are some of those internal features that make Python, well, Python?
One thing is how it handles errors. It uses something called exceptions.
Exceptions.
Yeah. So if something unexpected happens when your code runs, like trying to open a file that isn't there instead of just crashing.
Which is frustrating.
Very. Python has a structured way to, catch that error and deal with it gracefully. Makes your programs more robust.
Okay. Cleaner error handling. What else?
Patterson also highlights automated memory management.
That sounds important, but maybe a bit technical.
It is, but the effect is simple. You, the programmer, generally don't have to worry about allocating and freeing up computer memory manually.
Which you might have to do in C, for instance.
Exactly. That can be tricky and a source of bugs. Python takes care of it for you, mostly behind the scenes.
One less thing to worry about? Nice. Any other standout features?
Patterson mentions highly advanced features like list processing and generators. These are, let's say, powerful ways to work with sequences of data very efficiently.
Okay.
And he covers the fundamental data types. There's a good range.
Like?
Well, strings for text handling, both modern Unicode and older ASCII. Then you have dictionaries, which are key value pairs, lists,
We'll probably get more into those later.
definitely, and various kinds of numbers. Complex numbers, really big integers, floating point numbers for decimals.
So a good set of basic building blocks. The book also talks about organizing code into packages and modules. Why is structure like that important?
Imagine a really big project. If all your code was in one giant file, it'd be a nightmare to manage, right?
Yeah, finding anything would be tough.
So modules are basically files.py files where you put related functions and variables. Packages are like folders to group related modules together.
Keeps things tidy.
And reusable.
Exactly. Makes large projects manageable and lets you reuse code easily. Gotcha. And then there's typing. Patterson describes Python as dynamically and powerfully coded.
Yeah.
That sounds a bit contradictory, dynamic and strong.
It does, but it makes sense. Dynamic means you don't have to declare the type of a variable beforehand.
Like in C++ or Java where you say int x or string s.
Right. In Python, you just say x equals 5 or s ilo hello, and Python figures out the type automatically from the value.
Okay, that's the dynamic part. What about strongly typed?
Strongly typed means that once a variable has a type, say, Python knows x is an integer. It's strict about what you can do with it. You can't just add a number to a string without explicitly telling Python you want to convert one first.
Ah, I see. So it infers the type, but then it respects that type. Helps catch errors.
Precisely. It prevents certain kinds of nonsensical operations, catching potential mistakes early.
Okay, that clarifies things. Now, chapter 2 in the book moves to actually getting Python installed. Sounds like it varies a bit.
It can, yeah. Patterson points out that if you're on Linux or Mac OS, a version of Python might already be there.
Pre-installed.
Often, yes, though maybe not the latest version. He suggests checking and maybe grabbing the newest one from the official website, python.org, especially if you need newer features.
And for Windows users.
Usually not pre-installed, so the book directs you straight to python.org. They have simple installers there. It's pretty straightforward.
What about Mac specifically? Anything tricky there?
Well, Mac OS often includes an older Python. Patterson notes that if you install a newer one from python.org, you'll likely end up with both versions on your system, which is usually fine.
Okay.
He also gives a shout out to something called IDLA.
Ideal.
Yeah, the integrated development and learning environment. It often comes bundled with Python, especially on macOS. It's like a basic editor and shell to write and run Python code. Plus, it has built-in help docs.
Sounds like a good starting point for beginners.
Definitely. Very helpful when you're just getting your feet wet.
All right, moving into chapter 3, Patterson shares some useful tips. First up, dynamic input. We touched on dynamic typing, but how does this make things easier in practice?
It really speeds up the initial coding process. In those statically typed languages, you spend time up front declaring every variable's type. This will be an integer, this a string, etc.
Right.
With Python's dynamic input, you just assign values. My variable's 10, my variable hello. Python just figures it out. Patterson emphasizes this reduces the initial boilerplate code.
Less ceremony, more doing.
Pretty much, yeah. Makes experimenting faster.
Another tip, running scripts through Python. The example looks simple.
It generally is. On Unix-like systems, Patterson shows the command python-r and mypyprog.py. Basically, you tell the Python program to execute the code in your .py file.
Okay. And he shows combining strings, like text, is just using the plus sign.
Yep. Light plus saber gives you lightsaber. Very intuitive for joining text together.
Simple enough. The book then mentions dir and .doc. What are those for?
Ah, useful tools for exploring .dir, as Patterson explains. Shows you the names like functions and variables defined inside a module or object, helps you see what's available.
Kind of like looking under the hood.
Exactly. And .doc often gives you access to built-in documentation strings for that module or function. Tells you what it does, how to use it.
Handy for figuring things out on the fly.
Very much so.
Then there's the init method. Patterson calls it a constructor.
Yes, init. Those double underscores are common for special methods in Python. This one automatically runs when you create a new object from a class.
So when you make a new instance of something,
Precisely. Its job is usually to set up the initial state of that new object, like setting default values. Very similar, as Patterson notes, to constructors in Java or C++.
got it. He also mentions the Python interpreter for interactive coding.
Right, the interactive mode. You just type Python at your command prompt or terminal.
What does that
You
mean?
get a prompt, usually Herringbone. You can type Python commands one by one. hit enter and see the result immediately.
Oh, cool. So you can test little snippets of code instantly.
Exactly. It's fantastic for learning, experimenting, or just quickly calculating something.
Okay, here's a classic potential mix-up. The difference between Yingya and POC.
Yes, very important. Patterson makes this clear. Single equals is for assignment. X equals 5 makes X equal to 5.
Yeah.
Double equals is for comparison. X equals 5 checks if X is currently equal to 5 and returns true or false.
Right. Assign versus compare.
And Patterson points out an interesting safety feature. Python doesn't let you do assignment inside a comparison check, like if A equals B, which is easy to mistype in C, helps prevent bugs where you assign when you meant to compare.
That's smart. Another fundamental difference he highlights is code structure. Indentation and colons instead of curly brackets.
Yes, this is a big visual difference if you come from C++, Java, C#, JavaScript.
So, no semicolons at the end of lines.
Nope. Generally, the end of the line marks the end of the statement. And code blocks, like what goes inside an if statement or a for loop, are defined purely by indentation.
How much indentation?
Consistency is key, but the common standard is 4 spaces. A colon usually comes right before an indented block starts.
And Patterson says this makes the code easier to read.
That's the argument, yeah. It forces a certain visual structure, which many find improves readability.
Interesting. Then the book revisits modules for organizing bigger programs.
Right. As we mentioned, modules are those .py files containing your code. Patterson explains you use the import keyword to bring the code from one module into another.
So you can build up libraries of useful functions.
Exactly. Keep things organized, avoid repeating yourself, build larger applications piece by piece, like having specialized toolkits.
Okay, that makes sense. Chapter 4 then jumps into basic operators. Patterson defines an operator as something acting on values, like the plus in 3 plus 6 is mine.
And he lists out the main categories Python provides.
Let's see, bitwise, identity, arithmetic, logical, membership, relational comparison, and assignment. Quite a few.
Yeah, it's a comprehensive set covering different kinds of operations you might need to perform.
Maybe we can quickly touch on what each type is generally for without getting lost in the details.
Sure. Bitwise operators, they work directly on the individual bits of binary numbers, more low-level stuff usually.
Okay, identity.
Identity operators, is and is not, check if 2 variables actually point to the exact same object in the computer's memory, different from which just checks if the values are equal.
Subtle distinction. Arithmetic.
That's your basic math. Plus, extent, also things like modulus percent for remainder, and exponentiation.
Standard stuff.
Logic.
And, or, not.
Yeah.
Used for combining true-false conditions, typically in if statements.
Makes sense. Membership. That's in and not in. Super useful for checking if an item exists within a sequence, like a list or a string.
Oh, I can see that being handy. Relational comparison.
Those are the ones like and, not equal, and coming. Used for comparing values.
Right, for making decisions.
Yeah.
And finally, assignment.
Well, we saw the basic, but there are compound operators too, like plus. They perform an operation and assign the result back in one step. Like x plus 1 is shorthand for x equals x plus 1.
Okay, so a good range of tools for manipulating data. Then Chapter 5 gets into variables and types, and Patterson really hammers home that Python is heavily object-focused and not statically typed.
Yeah, he reiterates that point. You don't declare types. Everything's an object. The type comes from the value you assign.
Got it. So what are the core variable types the book introduces? Let's start with numbers.
Right. Python handles different kinds. You've got your standard integers, whole numbers, then long integers for, well, really big whole numbers, though in modern Python this distinction is less visible. Floating point numbers for decimals, and even complex numbers, which have a real and imaginary part used in some scientific domains.
And these just get created when you assign a number.
Pretty much. Minum x scales 10 makes an integer object. Pi x equals 3.14 makes a float. Patterson also mentions the del statement here, which you can use to remove a variable's binding to an object.
Okay. Next up, strings, text, basically.
Exactly. Sequences of characters. You define them using either single quotes, hello, or double quotes, world. Doesn't matter which, just be consistent. Patterson highlights the slice operators using square brackets with indices or ranges to grab parts of a string. Misstring 0 gets the first character, misstring 1.4 gets a substring.
And we already saw you can use plus to join them and to repeat them.
Yep, concatenation and repetition. Pretty straightforward string handling.
Lists. Patterson calls these the most flexible data type. Why so flexible?
Lists are ordered collections. You define them with square brackets, the items separated by commas, like 1 hello, 3.14.
So they can hold different types.
Yeah.
Numbers and strings together.
Exactly. That's a big part of their flexibility. They can hold anything, numbers, strings, even other lists nested inside.
Wow.
And critically, they are immutable. That means you can change them after they're created, add items, remove items, change existing items.
How do you access elements?
Yeah.
Same slicing as strings?
Yep, square brackets with indices. My list is the first item. Slicing works too. And there are methods like append to add items and ways to remove items using del or remove. Patterson dedicates a whole chapter later just to lists. They're that central.
Okay, sounds powerful. What about dictionaries?
Dictionaries store data not in an ordered sequence, but as key value pairs. Think of a real dictionary.
Right.
You look up a word, the key, to find its definition, the value.
Right.
You define them with curly brackets, like name, Alice, age 30. Here, name and age are keys, Alice and 30 are values.
And how do you get the value back?
Using the key in square brackets. My dict age would give you 30. Patterson notes keys are usually strings or numbers, and they have to be unique within a dictionary. He compares them to hashes or associative arrays in other languages like Perl.
Gotcha. Key value lookups. And the last one mentioned is tuples. How are they different from lists?
Tuples are also ordered sequences like lists, but you define them with parentheses, like 1, 2, 3.
Okay, so what's the catch?
The big difference Patterson emphasizes, tuples are immutable, read-only. Once you create a tuple, you cannot change, it can't add, remove, or modify elements.
Why would you want that?
Sometimes you want to ensure a collection of items doesn't change accidentally. They're also used in places where an immutable sequence is required, like as keys in a dictionary sometimes.
Okay, so lists are flexible and changeable. Tuples are fixed.
That's the main takeaway.
And the chapter wraps up mentioning data type conversion, so you can switch between these types.
Often, yes. Patterson explains Python provides built-in functions named after the types themselves. If you have a string like 123, you can use int 123 to turn it into the integer 123.
Or float for decimals.
Exactly. To turn things into strings, list, to turn, say, a tuple into a list, and so on. Useful for when you read data as text but need to work with it as numbers, for instance.
We have certainly covered a ton of ground here, digging into Python's basics with Tatterson's book as our map. It really does paint a picture of a language that's, well, powerful, but also quite user-friendly.
Absolutely. I think the key themes that come through are that clear, readable syntax, the power you get right out of the box with the standard library.
Right, and the fact that it runs everywhere.
Yeah, cross-platform compatibility. Plus that dynamic typing making it quicker to get started, and this really useful set of core data types, lists, dictionaries, strings, numbers, and the operators to work with them.
And for someone new to programming, it feels like the barriers are lower. You know, getting it installed isn't too bad. Tools like IDLE and the core ideas of variables, assigning values, doing basic operations seem, well, graspable.
I agree. Python really tries to smooth that initial learning curve while still giving you a tool that can scale up to really complex problems. It's a solid foundation.
So as everyone listening takes this in, maybe the question to ponder is this. Now that you've seen the groundwork, the focus on readability, the built-in tools, the flexibility, what kind of things could you build with this? What real-world problems or just personal projects does this basic understanding make you want to tackle?
Yeah, or which part of Python's wider world seems most interesting now? Is it web development, data science, automating tedious tasks? There are so many paths you can take from these fundamentals.
That really is the next step, isn't it? Take these ideas, maybe install Python if you haven't, and just start playing, experiment.
Exactly. That's where the real learning happens. Try things out, see what breaks, figure out why. Use these basics as your launchpad.